Good day, learners. Welcome to the discussion for geography in preparation for June examinations. We are going to start by looking at the outline of our paper. Our paper is structured for the June examinations. Right, we understand our full paper. The June examination will be a full paper. A full paper comprises of 3 questions. And the theory questions will be question number 1 on the atmosphere. And then question number 2 will be on geomorphology. Then as usual, our question number 3 in section B is geographical skills and techniques. So that's basically the structure of the junior examinations for geography grade 11. Right, so we'll just be highlighting some of the questions and just discussing some of the key aspects that you must be aware of as you prepare for the junior examinations. Right, we're going to use this paper as a sample paper for the discussion. Our core focus here is to elaborate on some aspects and also to give some hints on how best you can attempt answering the questions. We'll start with question number 1, which is on the atmosphere. And we have multiple choice questions. We're just going to highlight on key aspects of the multiple choice questions. Lines on a map joining places of equal temperature is known as, right? The correct response there is isotherms. That is the correct response. Isotherms, that answer. Isotherms, we are saying these are the lines that join places of the same temperature. Places of the same temperature, they are joined by the isotherms. Right. Then we move on to the next question. The next question is talking of the weight of the atmosphere. The weight of the atmosphere on the surface of the Earth is the dash. Right? The weight of the atmosphere, in this instance, our weight of the atmosphere is the atmospheric pressure. So atmospheric pressure is the correct response for that question. Then we move on to the next question. The next question is on air which moves from high pressure to low pressure is, what do we regard air which moves from high pressure to low pressure? Air move from high pressure to low pressure is pressure gradient, which is D. When you're looking at the differences in pressure, if you're having two places with differences in pressure, with one area having a higher pressure and the other area having lower pressure, we have what you call a pressure gradient existing between those two. And if there's pressure gradient, it will also imply that the two places will have the difference in pressure, and that difference is the one that will tend to drive the air from the place with high pressure going to the area with lower pressure, because of the existence of pressure gradient between the two places. So because of that, we tend to find that we have pressure gradient, and that is what drives the air from one place to another. Right. Then we also have the amount of change in atmospheric pressure between high and low pressure area. We've talked about that. Then dash is mid-autumn days that fall on the 21st of March when there is equal length of day and night. When there is equal length of day and night on the 21st of March. Remember, when you're looking at the rotational and the revolutional effect of the Earth around the Sun, we tend to have what you call the equinoxes, and we also have what you call the solstices. The equinoxes represents a situation or present a situation whereby the day number of hours is equivalent to the night number of hours. That is an equinox. Then when we have a solstice, we are saying if it's winter solstice, it means we have more hours of night than hours of daytime. Then also we have a summer solstice, where we have a longer day and a shorter night. So in this instance, we're talking of the 21st of March as our reference day here. That qualifies to be an autumn equinox for that response. All right. Then we move on to the zone where two sets of tropical easterlies converge is the zone where two sets of tropical easterlies converge. That is the intertropical convergence zone, the ITC Z. That is where we tend to find that the tropical easterlies, they tend to converge around that area of the ITC Z. The next question is question number 1.1.7. It says the dash is the force which deflects winds due to the Earth's rotation. The Earth's rotation, as the Earth rotates, it tends to deflect wind into a given direction or to a given certain direction. Right. It's because of the Coriolis force. Our response is A for that question. Coriolis force is the one that is responsible for driving of air from for the deflection of air to the left in the southern hemisphere and to the right in the northern hemisphere. That is the relative deflective direction, which is caused by a Coriolis effect. Apparently, we are saying with Coriolis effect comes into play because of the rotation of the Earth. As the wind blows over the rotating Earth, it won't maintain a straight course as suggested by pressure gradient force. Pressure gradient implies that the winds are supposed to move from high pressure going towards low pressure in a straight course. But however, that straight course is not achieved because the wind is also moving over a moving body. The Earth is rotating, is also moving, while the air is also trying to find its course on a moving body. So at the end, the air is deflected in a given direction because of that effect of Coriolis, which is caused by the rotational force of the Earth. Then the last question on multiple choice is question number 1.18. The dash zone, the zone where two air masses of different temperatures meet is. Now we are looking at two different air masses of different temperature. That is the polar front. We have the polar front, which is B. That is where we tend to find the two air masses of different temperatures meeting there. So basically, we can just highlight our responses as we've discussed. We said this isotherm, and we said that the weight, this is atmospheric pressure. And also we discussed about air which moves from high pressure to low pressure is air which moves from high pressure to low pressure. So it is the wind, and the amount of change in atmospheric pressure between high and low pressure is known as amount of change, that is the pressure gradient. And also we said that this is autumn equinox. And then we have number 6, where there's one way two sets of tropical easterlies. We said that is the ITCZ. And lastly, the force which deflects is the Coriolis force. And finally, there's one way two air masses of different temperatures meet is the polar front. Right. That is basically how we can attempt to answer multiple choice questions. And also remember, you need not to give two responses for multiple choice questions. You can never give two different responses, like you say A or B. There is only one correct response for a multiple choice questions. Right. Then we move on to the next item. The side of a mountain where winds are descend and warm up as the dash side. We are looking at two sides of a mountain. I think you still understand. We are having one side. If this is a mountain, let's say this is the side where the wind comes from. It is forced to rise. There is condensation that is going to take place. Clouds, they do form, and the wind continues going down. As it goes down, it becomes dry and hot. Right. So this side is where the wind is coming from. we are saying this is called the windward side. The side where the wind comes from is the windward side, and the other side is the leeward side. So it's windward, then leeward side. So for our response here, we are looking at this side. This air is going to lose moisture because of condensation that has taken place, and precipitation is going to be received on this side, which is called the windward side. As the air continues, it goes down, it heats up adiabatically. We talk of adiabatic heating as it goes down. That is why it becomes hot as it gets down, like the formation of the foehn winds. They become hot and dry on the other side of the leeward side of the mountain. Right. So is for this instance, our response is the leeward side. Then warm, dry wind that descends on the leeward side of a mountain. The warm, dry wind that descends on the leeward side. We've talked about that. That is typically the foehn wind. Then the rate at which the temperature of dry unsaturated air decreases with an increase in height. At 1 degree Celsius per 100 meters is it the dry or the wet adiabatic lapse rate? We are looking at dry unsaturated. So that is the dry adiabatic lapse rate, right? The rate at which temperature changes in the atmosphere with change in altitude is it temperature range or lapse rate? The correct response is lapse rate. Temperature range is the difference between the highest temperature recorded and the lowest temperature. If you are looking at the temperature range for a given day, we are saying the highest temperature that was achieved during that day when the temperatures were very high, less the lowest temperatures when it was excessively having a lower temperature. That difference is the temperature range. Then a change in conditions brought about by wetter conditions in the Pacific Ocean is known as El Nino or La Nina. This is typically the La Nina situation. The difference between summer and winter temperatures is temperature range or lapse rate. We have just talked about that. Is temperature range. The temperature range, we have the highest temperatures during summer season and the lowest temperatures during winter season. So the difference between the two gives us the temperature range. A seasonal wind that blows in the tropical region is what do we call a seasonal wind that blows in the tropical? It's a monsoon wind. Remember, we talked about the monsoon winds. We will discuss down the monsoon winds because typically the monsoon winds is a regional wind. We regard it as a regional wind. It affects a specific area. It's only specific. Like, for example, you talk of a typical example of India. They experience the typical monsoon conditions. Is a regional wind in that particular area which changes directions with changes in seasons. It's a seasonal wind. Right. So we move on to the next question. Next question is on the model of global air circulation, including the pressure belts and also including the circulation cells. Right, I want to explain on that model before we try to figure out responses to the answers. I just want to highlight on some of the key aspects of the working of the model of the tricellular global air circulation. Right, what happens here is we have this globe or model of the globe, and right on the midpoint here, we have our equator around 0 degrees, right? And then this belt here, this is a low pressure belt. A low pressure belt because of intense heating. The sun is always directly overhead from around 23.5 degrees north and 23.5 degrees south. we have our tropical region, and the sun is overhead and resulting in intense heating, which causes low pressure in that particular belt. Then we move on to the subtropical, which is around 30 here. This is a high pressure belt, right? And this is high pressure because there's sinking air around 30 here. The air which arises around the equator, it sinks in that region there. And then we have the subpolar. This is a low pressure zone, a low pressure belt. It's a low pressure because of the relative deflective effect of the wind, because there is increased Coriolis effect and there is more relative deflection, such that there is low pressure in this belt. And then lastly, the polar is a high pressure belt. So that's the distribution of our pressure belts on the global scale. We have also the same sequence going towards the south. This is the subtropical south, it's a high pressure, and the subpolar south is a low pressure, and then the polar south is a high pressure. Right, and therefore, because of this distribution of pressure belts, we tend also to have some circulation cells that develop. We have this one here, which is called the Hadley, which is in between the tropics and the subtropics. We have the Hadley cell, then we have the Ferrel cell, and then lastly we have the polar cell. Those are the three cells of circulation that are as a result of the distribution of the pressure belts as they are distributed like that on the global scale. Right, we also need to look at the planetary winds which result from this. Right, remember we said for us to understand the planetary winds, we need to analyze the effect of Coriolis, the Coriolis effect. There is what we call the Ferrel's law. The Ferrel's law explains the effect of Coriolis on winds in the southern hemisphere and in the northern hemisphere. And according to the Ferrel's law, it says deflection is to the left in the southern hemisphere. Winds are deflected to the left in the southern hemisphere and to the right in the northern hemisphere. So, because we have differences in pressure, there is pressure gradient, and the pressure gradient will cause winds from high pressure to low pressure. But however, the winds will not achieve a straighter course like this. The winds will not move from high pressure to low pressure in a straight course because it's also being driven and it's also being deflected by Coriolis force. And they are forced to twist to the left. That is why you tend to find that our winds now are going to the left. We are in the southern hemisphere. They are going to the left. And from high to low, they are also twisted to the left like this. Remember, this is left. We're coming from north going to south. And this is left. We're coming from south going to north. They are pointing to different directions, but both of them, they are deflecting to the left. It's only because of change in movement direction. When you are coming from the north going to the south, your left is going that direction here. And when you're moving from south going to north, your left is here. Then we also have this deflecting to the left in the south, and in the north, they are deflecting to the right. So these planetary winds here are what we call these ones, what we call the tropical easterlies. And what we have here is what we call, this is the tropical easterlies and the tropical easterlies. Then we have a belt of the westerlies. And then lastly, we have this belt of the polar easterlies. These tropical easterlies are also called the trade winds. In other texts, you find them labeled as trade winds. It's one and the same thing, the tropical easterlies and the trade winds. So moving on to our questions, we're going to use this information here to try to apply it to the given questions. Identify the pressure belts A and B. Supposed to identify the pressure belts A and B. A, we have already mentioned that this is A is equatorial, low pressure. You're not just supposed to say a low pressure or indicating the pressure. Indicate the correct name according to location and the nature of the pressure. And then B, our B is here. This is the subtropical high pressure belt. So those are our two pressure belts, the subtropical pressure belt, high pressure belt, and the equatorial low pressure belt for A. Right. Then we'll move on to the next question. Explain why planetary winds identify planetary winds that develop at D and E. I think we've discussed about that. At D and at E, planetary winds that develop at D and E. Right, we are seeing our D there is representing the tropical easterlies. As we can see, D is representing our tropical easterlies. Here, D is here. So D, that is the tropical easterlies. And our E, as we can also see, they are the westerlies. Right, those are our planetary winds. Explain why planetary winds identified show a deflection. Why do they show a deflection? Like what I've mentioned earlier on, when we are explaining about the deflection, we are saying they are deflected because of the effect of Coriolis. Because of Coriolis effect, we tend to find that the winds are deflected to a given direction. And according to the Ferrel's law, they are deflected to the left in the southern hemisphere, and they are deflected to the right in the northern hemisphere. So explain basing on the idea of Coriolis effect that causes the winds to deflect in a given direction according to the Ferrel's law. They name the tricellular cell which develops at F. I think we've also mentioned that. At F, we have our Hadley cell. This is our F. We have a Hadley cell to the south and a Hadley cell to the north. This is also the Hadley. And we want another. We'll go to the next question. Describe how cell F develops. How does the Hadley cell develop? A cell is continuous. We can start at any point. I will start from this particular point here. Right. There is intense heating of the ground surface, and the air immediately above the ground is heated. It becomes less dense and it rises. What is going to happen as it rises? It is cooled as it gets in upper atmosphere. It is deflected polwards. It goes in the upper atmosphere, is cooled, it becomes more denser, and as it is denser, it is deflected to the pole direction. What is going to happen? It becomes heavier because it's now cooler, and it sinks around the 30 degrees south or 30 degrees to the north. They sink here. As the air sinks, it creates a high pressure. And here, because there's low pressure, because of intense heating, there's pressure gradient between these two. So the air which is sinking here, it is drifted towards the equatorial region where there's low pressure. Again, as it gets here, the temperatures are higher, it's heated, it becomes less dense, it rises. That is basically how you explain this circulation cell. It's a circulation cell, and with a circulation cell, you can start your explanation of at any point. You can start with sinking air here. The sinking air creates high pressure, and it is forced because of pressure gradient force to go towards the pole, towards the equatorial region where there's low pressure. And at the equator, it's what? The air is heated by the hot ground, and it loses its density. It becomes less dense. It rises. So basically, you can explain a circulation cell in any of those directions. Right, the subpolar low pressure belt is located at C. Explain how it is possible for a low pressure cell to develop at such a high latitude. A low pressure is developed. Why a low pressure cell to develop at such a high latitude? Right. This is a low pressure. Why is it possible to have a low pressure at high latitudes? We know that at high latitudes, mainly our pressure system is affected by the temperatures. We know that the temperatures are relatively lower in high latitudes. So why can we tend to have low pressure? in that area of high latitude. So we can argue that why is it possible? Or argument, we can argue on the divergence from 30 degrees are warm and flows to 60. And then cold polar, the cold polar easterlies, we know they are coming from 90 degrees to 60. What will happen? There's convergence there of the cold. This is along the polar front. Remember, we're talking of the polar front here, around 60. At the polar front, we have cold air. We got illustration here, using this illustration. We are having around 60. That is where we have our polar front. And we are saying, why is it possible that we have lower pressure in that region? And we are having a high latitude. We are supposed to be having high pressure in higher latitudes. Right. So we are saying around this area here. Let me illustrate the polar front. We have our polar front, which is the boundary, which is going to split the cold tropical easterlies and the warm westerlies here. The westerlies are coming from 30, it's warm, and here it's cold. So the winds coming from here are going to this direction, and these ones are going there. They are going to converge along the polar front. So what is going to happen? Because this one is colder and denser, is going to force this one to uplift. So the upliftment of the westerly winds as they converge with the polar will create a vacuum. Because this air is going to be forced to uplift along the polar front. As it uplifts, it means it now leaves a low pressure because of its displacement. It's going to be displaced. The two air masses are going to converge. A colder polar easterly is going to converge with the warmer westerly winds along the polar front. And as a result of the differences in density, the warmer air is forced to rise, and that will ultimately create a vacuum that will lead to a low pressure developing around that belt of 60 degrees, which is a high latitude. That is basically what you can use as argument to substantiate the validity of having a low pressure in high latitude. Right. Then we'll move on to the next question. Right. The next question is refer the infographic on Africa's weather and climate. Right. On Africa's weather and climate, what are we supposed to look at? What are we supposed to analyze? Right. We are supposed to check on ocean currents influence the weather of the coastal areas. Due to evaporation from the oceans, the winds blowing from the sea to the land carry moisture onshore at coastal at end. Right, that's the situation. We are trying to compare the temperatures of places and the influence of ocean currents on the temperatures of given places in South Africa. Right, so we are going to attempt our questions based on the infographic provided. Define onshore winds. That's the first question. When we're defining onshore winds, we are looking at onshore winds which are incoming. Then offshore is outgoing. That is what you must note. When you talk of offshore, it means it's outgoing. Then onshore is incoming. So our onshore winds, we are saying, winds which come from the ocean to land. This is onshore. And winds which are coming from the land going to the ocean, these are offshore and on. So basically, you define according to that understanding of the direction of movement of air from water to land or from land to water. Off, outgoing from land to water. On, from water to land. Use the information from the infographic and determine which city has the smallest temperature range. Basically, we are comparing the cities' differences in temperature between the maximum and the minimum. We want the one with the smallest temperature range. If you use the idea of the influence of ocean currents, you can find out which city has got the smallest temperature range. They must be just closer to each other, the highest and the lowest. If we check here, it's 24 and 4, which means the range here is 20. There's 21 and 3 here, which suggests it's 18, 30 and 9 is 21, 25 and is 20, 24 and 6, 21 and 6, 21 and 3, 21 and 6, 19 and 12. What's the difference there? If you check 19 and 12, the difference is 7. And the difference here, 13 and 25 is almost 12. Then 25 and 10 is 15. So basically, the one with the smallest temperature range, you tend to find that is the one with the smallest figure of difference. Identify ocean currents A and B, which influence the climate of South Africa. You just have to check on the map and see the ocean currents, which influence the climatic conditions of South Africa, right? If we check here, you find that this is the Indian Ocean on the east and the Atlantic on the west. So the ocean currents that tend to move here is coming from the equatorial region, which is a warmer region, and we tend to have a warm ocean currents, which is the warm Mozambique current. And then here, this current A is ultimately coming from the polar region going to the north, which means it's a cold. So this is the cold Benguela current. Right. Explain why ocean current A is responsible for cold and dry west coastal conditions. For cold, we are saying the ocean current comes from the cold polar region, and hence it brings in cold conditions to the west. Because it's cold, it's coming from the cold polar region, it's coming from the south here. So it's cold, it brings it with cold conditions on the west. And dry, it also because onshore winds are cold and dry. The cold winds have no capacity to contain moisture, and hence they cannot effectively cause precipitation on the west. That is why the west is always dry. It's because of the nature of the air, which is dry, which is cold and dry from the cold ocean current on the extreme west. Then in the paragraph of approximately 8 lines, discuss the influence of ocean currents B in question 143 in the temperature and rainfall of Durban. We want to analyze the warm Mozambique current here. The warm Mozambique current comes from the warm tropical region, and hence it brings it with its warm conditions over Durban. So if you check the temperature over Durban is relatively higher because of the influence of the warm ocean current. It brings with it relatively warmer conditions over Durban. It's relatively warm there. And also, when you're looking at the influence on rainfall, you explain how the warm ocean current brings in a rainfall to Durban. Onshore winds are warm and moist because of the warm conditions of a Durban. If air is warm, it has capacity to contain moisture, and hence, as the air is uplifted as it gets inland will reach dew point and condensation will effectively take place, resulting in rainfall over Durban. So that is basically the idea of what you must highlight, what you must explain along to justify the fact that there is rainfall and warmer temperatures over Durban there because of the warm ocean current, which is the Mozambique current. Right, moving on to the next question. So ensure also when you're answering this question, you give responses on temperature and also you respond on rainfall. You must not just respond on one aspect, respond equally on the two aspects in the question so that you balance your discussion and you will be able to get your 8 marks for the paragraph. Right, I'll move on to the next question. The next question is based on an infographic on desertification. Right, we cannot read through the text, but we'll just highlight and try to figure out how best we can answer the questions. The first question is saying, define the term desertification. Desertification is a term which is derived from a desert. The term desert. When we are desertifying, what are we doing? Desertification. Right. So we can describe it as the change or the transformation of areas that were once suitable for agriculture into deserts. We are saying some areas which were conducive for agriculture, they were supporting crop production, they were supporting animal production initially. But however, they are gradually changing into desert conditions. We know that the desert is not that productive in terms of agriculture. So if an area which was once suitable for agriculture is being transformed or is gradually changing into desert conditions, we are actually causing desertification in that particular area. Then identify the continent with the highest rate of desertification. If you check on the pie presentation here, Europe has 2%, Oceania 2%, unspecified 18, Latin America 12, Asia 27, Africa 39. So Africa, according to the comparison, the relative figures there that we have, it has the highest of 39%. So it was the one which is the highest rate is African continent is the one which is having the highest rate of desertification. Right. Quote 2 causes of desertification from the text. We go to our text and just try to identify. Desertification can be caused by drought, overpopulation, overfarming, deforestation, and climate change. Those are the causes of desertification according to the extract. You just have to extract 2. We have 1, 2, 3, 4, 5 of them. We just extract 2 from those 5. Discuss the economic implications of desertification on the areas mentioned in 1, 5, 3. The economic implication, we want to look at how desertification affects the way of life of people. The way of life of people, how is it affected if the areas are gradually changing into desert conditions? What is going to happen to the lives of people? Right. So if we check there, so before we look at that, in which region is the most vulnerable? Which region is the most vulnerable to desertification on the continent identified in? Right. We also want to look at the region. We had skipped that question. This is the Sahel region. The Sahel region, we're looking at the areas surrounding the Sahara Desert. They are threatened by desertification because the Sahara Desert is extending into those areas, is ultimately threatening the areas around. There is a high rate of desertification in areas around the Sahara Desert, which we term the Sahel region. Is very prone to desertification because of the extension of the Sahara Desert conditions. Right, then we'll look at the next question, which talks about the implications of desertification on the areas. When you're looking at economic, look at something to do with making money, the ability to make money in the areas. How is it impacted? You can talk of the implication in agriculture. It reduces the agricultural yield and hence low income for the farmers. Or you can talk of it impacts on prices for food prices, and hence people will be made to pay more in terms of food commodities because of a shortage which is going to be created by desertification. You talk of its implication on employment levels. People are going to lose jobs because of the desertification. For example, people in agriculture and related industries, they're going to lose their jobs. So you discuss anything to do with the people's ability of making money. How is it impacted by desertification? Then you explain. Then our last question, this area is under constant stress due to frequent droughts. Suggest management strategies that can be implemented to reduce the risk of drought in the areas mentioned. You are supposed to come out with, you think outside the box. You don't need to think from the textbook. Find responses that can counter drought. What can we do to counter the effect of drought? We are saying there is limited rainfall. There's less than average amount of rainfall received in the area. What can we do to counter that effect of having less rainfall? You can suggest measures like coming out with drought-resistant varieties, or you can talk of farmers. You can talk of a research on crop varieties that resist drought, or you can talk of how to manage water resources, the different ways of how to conserve water resources. You can ultimately argue along those lines. You can talk of education as a weapon to equip people to be able to come with suggestions and solutions to the problem of drought. You can talk of humanitarian aid, though it's not a reliable measure, but in cases of crisis, it can assist humanitarian aid. So you discuss along those lines, and basically that takes us to the end of our geomorphology question. Then we go to our atmosphere question. We go to the geomorphology question, which is question number 2. Like question number 211, it says a slope which is curved inwards so that the lower part of the slope is flatter and the higher part of the slope is steeper. But I think when we're looking at the kind of slopes, the description here is giving us something like this. It's a slope like this. It says it's curved inwards so that the lower part is flatter. This is the lower part, and steeper. This one is steeper here. This is the nature of the slope. So this kind of slope is what we call the convex. And the opposite, if we have a slope like this, it's a con. This is a concave. And this is a convex. And then we also have what we call a regular slope. And then we can also have a terraced slope. A terraced slope is something like this. This is a terraced. So we have a terraced slope, a regular slope, and then we have a convex, and then we have a concave. A concave slope, a convex, and ultimately that last kind of a slope. Right. So what you need here is for you to analyze the nature of the question and be able to come out with the right response. So this one here is concave. It's a concave slope for that response. Then erosion and landmass in such a way that landforms becomes narrower is because of backwasting process. Backwasting process like scalp retreat you tend to find that the landforms, they become narrower. The way through which a plateau reduces its size to become a mesa and to become a butte and gradually becoming a conical hill and flattening out to become a flatland. That is because of backwesting processes. The breaking down of rocks due to extreme temperature is, by temperature, is mechanical weathering. Like processes like exfoliation is part of mechanical weathering. It's caused by mechanical processes, or what you can call physical weathering. Then chemical weathering is caused by mainly moisture reacting with minerals in the rocks such that they rot. Processes like oxidation are part of chemical weathering. Right. Then a steep slope of a ridge is the right. The steep slope is the scarp. We have the scarp slope, then the deep slope on the other side. Then horizontal layers of magma intrusions are, a horizontal layer is a seal. The seals, they are formed as a result of horizontal intrusion between rock layers. Like if we are having a rock layer and we are having another rock layer, then there is a gap between these two layers here. Then the hot liquid magma will find its way filling in the gap between the two. And this is a seal. Right. Then a mushroom-shaped intrusive feature, mushroom-shaped. Remember, when I'm talking of a mushroom-shaped, we are saying it's like this. And then we have a saucer-shaped intrusion. This is a saucer-shaped, and this is a mushroom-shaped intrusion. Right. So you must note between the two, the difference between those two. Right. A lapolith is this, and a lacolith is this. So in this instance, we want a mushroom-shaped. A mushroom-shaped is a lacolith. Then the largest dome-shaped intrusion of magma deep within the Earth's surface, a largest dome-shaped. Dome-shaped, we are looking at a feature which has got a dome shape. But we want here, for this instance, we want the one which is the largest. Remember, on the intrusions, we can have some other dome-shaped features, but the difference lies with the size. It lies with the size. We want now the biggest intrusion of those landforms which are intrusive. We have the batholith as the largest, and that is where our granitic domes will originate from, the batholith. Right. So basically, those are the responses to our question. Right. We move on to the next question. We need to move on to question number 2.2 and see how best we can attempt the given set of questions. Right. Moving on to question number 1.2, 2.2. It's a matching item question where we're supposed to match the description in column A with a response in column B. The largest area with deep, steep-sided valleys with narrow valleys. What kind of a feature is that? Where we have deep, steep-sided valleys. Among us, this, the correct response is a canyon landscape, C. Right, then the plateau is reduced in width due to the process of backwesting. I think you can see this is giving us a clue of the last question. Of the previous question, number 2.1, is talking about backwesting and is talking of a rejection of width. There, by creating this feature, which feature is created as a result of backwesting of the plateau. A plateau will get reduced to become a mesa, which is G. Flat-topped hills with a greater height than width. The height is greater than the width, but it's flat-topped. A flat-topped with greater height than width is a butte. Landforms where the resistant cape rock has been removed. Now the Cape Rock, which was protecting the landform from extreme erosion and backwasting processes, if it's completely removed, what kind of a feature is that? Right, that is a conical hill, which is I. A conical hill does not have a cape rock on top. A flat large area elevated above the sea level. A flat area elevated above the sea level. That is definitely a plateau, which is D. Hard resistant rock found on top of horizontal features like mesa and butte. What do we call that hard resistant rock? We've been talking about that. The response is even here is the Cape Rock, which is F. Then landscapes that consist of flat-topped mountains of different width. Flat-topped mountains of different widths. We are looking at the mesas. We are looking at the butte. We are looking at the plateaus. They are coexisting in a given area. What name do we give to that landscape? That is the Karoo landscape, which is H. Then the process of backwasting is also referred to as, what other name can we give? Is parallel retreat, which is E. Right, those are the responses to question number 2.2. Right, moving on, we need to check on the next question, which is question number 2.3. Right, 2.3 shows the topography associated with inclined strata. Inclined rocks, they give us that particular landform. Right. Identify the landform in Fig 2.3. What kind of a landform is that one? That is basically a Kester basin. It's a basin, right? And does this feature occur in inclined or horizontal? Definitely that is inclined strata. They do occur in inclined, not in horizontal. Does label slopes A and B. Slope A, if you check, is the deep slope, is the gently sloping one as we get inside the basin. And A is the steep one, which is the scarp slope. Describe the steepness of the slopes mentioned in question 2.33. This one here is gently sloping. The deep slope is gently sloping. And this one is steep sloping. That's the differences in the two slopes. Discuss how this landscape can be utilized by humans. We'll see how the basin can be utilized by humans. We are justifying the use of that landform by humans. We can talk of harvesting of water in the basin. It's probable that water can be harvested in the basin there. And you can also talk of related activities to do with that particular landform. Remember, you're supposed to justify how people can benefit from that particular landscape, how people can benefit or how people can utilize that particular landscape and be able to derive a benefit from that particular landform. How can they benefit from that particular landform as human beings? So you can use for groundwater. You can use a center for a good source of groundwater as one response. They can benefit by extracting groundwater. Then you can also get water for irrigation. The basin. The basin can be a good source of water for irrigation. You justify along those lines how people can utilize that particular landscape. All right, we'll move on to the next question. The next question is talking about the formation of the tuffs, the granitic tuffs as part of the topography, the topographical features that we find from massive igneous intrusions. Right, that is basically our illustration of the typical landform that we want to look at. Right. So if we look at this, we are finding that the first question is saying provide a definition for tuffs. What is required there is for you to address the concept, not for you to try to memorize how it is defined as exactly as it is in the textbook, but however, you must just try to give geographically valid description or definition of what tuffs are. From what you are seeing on the illustration, we can derive a definition from what we are actually seeing there. It's not like we need to crack to memorize how a granitic tuff is defined. So basically, as you are seeing there, it's balancing core rocks that you are seeing. Rocks, core rocks or core stones, one on top of the other, which are balanced. And they originate from massive igneous intrusions. This is a landform resulting from igneous intrusion. And how does it look like? It's balancing rocks or balancing core stones. It's a topographical feature which consists of balancing core stones and which is of igneous intrusion origin, massive igneous intrusions. Basically, if you highlight those ideas, then you have justified what granitic tuffs are. They name two types of weathering that is responsible for the formation of this type of landform. Basically, this landform here is as a result of chemical weathering taking place when the rock is ultimately underneath the Earth's crust. There is chemical weathering which takes place there as moisture seeps into the ground. It gets to react on the cracks that would have formed as the massive igneous feature is cooling down. So there's chemical, then there's also mechanical weathering or physical weathering, which tends to affect the landform as it is exposed outside. Name the original landform from which the tuffs depicted in Fig 2.4 are developed. We are looking at the intrusive landforms. Remember, we talked of quite a number of landforms, and mainly our granitic tuffs, they originate from the batholith. Explain how this landform can be an economic advantage for local community. How can people benefit from this? You can talk of tourism. You can talk of sightseeing. You can talk of the economic benefit of the rocks as they are. These rocks are of volcanic origin. They can be used for different construction purposes. So you justify how these landforms can be beneficial to the people. Local community, how can they benefit from the existence of such features in their area? Then describe the formation of tuffs. Right, when you're describing this, you're supposed to start by describing them as intrusive features. Intrusive, there is intrusion of magma there, and the magma cools. As it cools, you explain that cracks develop. What will happen to the cracks as they develop? There is also seeping in of moisture into the cracks. They widen because of chemical weathering. Chemical weathering will further widen the cracks that would have developed as the magma cools down. And with those cracks being further enhanced by chemical weathering, we tend to find that the feature is weathered into core stones, and the feature become exposed. Remember, it was forming underground. Chemical weathering was happening as the feature was still hidden underground. But because of erosional processes, the landform become exposed. And it become exposed as core stones, which will be balancing. So basically, that's the process that you have to explain when you're explaining the formation of granitic tuffs. Right. Then we'll go to the next question. The next question is an illustration on slope elements. We are analyzing slope elements. Right, on slope elements, what we need to check there is to try and figure out how we can analyze the different elements of a slope according to the illustration that we have. Right, name the slope elements A, B, and D. Right, if we analyze our slope here, the slope elements that we tend to find here, our A is the crest. And B, this almost vertical slope, part of the slope, is what we call the cliff of the slope. And then our D, this part which is lower, where vegetation grows and where the soil is fertile because of weathering taking place there, where that material deposited on the lower part of the slope, is what we call the pediment. Right, those are the three: the crest, which is the uppermost part, where, and the almost vertical slope is a cliff. Then we have a pediment. Right, define the concept nick point. What is a nick point? I think it's slightly defined for us here. A nick point is a part on the slope where there is a sharp change in gradient. On a nick point, gradient just changes sharply. We are having a slope like this, then all of a sudden, this is a nick point. There's a sudden change in gradient on the slope. Where there's a sudden change and a sharp change in gradient is what we regard as a nick point. Like what is indicated there, as we are coming from this part going down there, there's a steep change in gradient. There's a sharp change in gradient. That is basically what we regard as a nick point as a part of the slope. Then the next question is saying, why would farming activity be practiced on slope D than on the slope C? Why would we do farming on slope B here? Right, one reason for slope D here, you can see that it's gently sloping, making it easier to do farming. It's gently sloping, this part here. So because of the gentle slope, it makes it easier to do farming or to use farming equipment and machinery there because it's relatively gentle. And then it makes it feasible to do agriculture or to support agriculture. Or you can also argue on the quality of soil. There's fertile soil there. Fertile soil, because of weathering taking place on the upper part of the slope, the weathered material is gradually brought down to the pediment, and hence there's fertile soil. And also there are deeper soils there. The soils are deeper, which can support effective farming. Right. In a paragraph of basically 8 lines, discuss one characteristic of each slope element labeled A to D. Discuss one characteristic. So you're supposed to describe the characteristics of the slope elements as indicated on the labeled parts of the illustration. So you start with the first part here. You explain the nature of the slope there, and you explain the processes that might be taking place there. Like talk of mass movement process is most likely to happen at A. There's gradual movement of material like soil creep is the uppermost part of the slope. As you go to B, you are explaining now the slope of the part of that slope element. You can see that is very steep sloping. It's almost vertical. That is where we find activities happening there, like rock falls can happen on that part of the slope. Then as we go there, you explain the gradient at C. What kind of gradient, what kind of processes are most likely to happen there? You tend to find that because of the slope is relatively steeper sloping, there are mass movement processes which are a little bit faster. Then as we go down to D, you explain the slope of the gradient and the processes that are likely to take place there. What kind of material is found in D? Eroded material from the upper part of the slope. There's fertile soil. There are deeper soils there in area D. So basically, you highlight on those parts of the slope and try to justify and explain along those lines as part of the features of those slope elements. Right. Then we need to check on our map equation. Our map equation, question number 3, is based on ML or map. And most of the time, I encourage or I advise people to look at the map information before they try to answer the question. Usually, learners tend to ignore the map information. The map information is equally important because it will assist you in answering some of the questions. Right. Then you go to your question. Right. The first question is saying the contour interval on the orthophoto map is dash meters. Right. If we check on the orthophoto map, we have our standardized intervals for the topographic map and for the orthophoto map. You check here, it is indicated contour interval 5 meters as indicated on the map here. If you check, clearly it's indicated, the interval is indicated, contour interval in Afrikaans and in English. What is the contour interval? We are saying is the difference in height between two successive contour lines. If you are having one contour line here, and then the next contour line is here, the difference in height, if this contour line is 100, it means if you are going up the slope, the next contour line is going to be 105. They are differing by 5. The next one, if you are going up slope, is going to be 110 meters. That is the interval that we are talking about. So for the topographic map, the contour interval is also indicated. 5 meters is for the orthophoto map. And for the topographic map, if you check here, the contour interval is also indicated. See here, and it's also indicated there. For the topographic map is an interval of 20 meters, which means the value of two contour lines next to each other, they differ by 20 meters in value of height that they represent. So that guides us. For the orthophoto map, our correct response must be A. It's an interval of 5 according to the map. The map index, 2629 dB, is 26 referring to, when you are referencing, remember this, we start with latitude, then this is longitude, then this is bigger block subdivision, then this is smaller block subdivision. That is how we do our referencing. So 26, 29, 26 latitude, 29 longitude, then D for bigger block subdivision and B for smaller block subdivision. So our correct for 26 is 26 latitude. Refer the topographic map and orthophoto. Determine the true bearing from trigonometrical station 305 in block D2 to the benchmark in block D1. We want to determine true bearing there. When you are determining true bearing, what you must just supposed to do is to identify the two features. we have trig station 305 in block D2 and benchmark D1. Right, D2, we have this station and benchmark in D1. The benchmark is here. So these are our two features, the station and the benchmark. We want to determine the bearing of this benchmark from here. So what you need to do is you come with your ruler. You are supposed to draw a straight line going through the center of your trig station. You draw a straight line. This line must be parallel to your lines of longitude. You must draw a line which runs parallel to your lines of longitude. And what is the implication? If you draw a line which is parallel to your lines of longitude, you are pointing to your true north direction. Then from the feature here, connect your point, your benchmark. You draw a straight line connecting the two. So when you are measuring your true bearing, you are supposed to calculate the angle size in a clockwise direction, starting from your true north. Already your true north is here. This is the direction of the true north. So what you're supposed to do is you have to measure the size of this angle here until this line connecting the two. That is the angle that we want. Automatically, this angle we know, you cannot need to measure here because we know it's a straight line. It's 180 degrees. We need to measure the additional angle here and add it to 180. So 80 plus this size of the angle, that gives us the value of our true bearing. If you measure correctly, your angle must be around 244 degrees. That will be your true bearing. If you measure accurately by placing your protractor correctly and drawing your markings correctly, you'll get approximately an angle of around 244 degrees. Right, then we move on to calculate the present magnetic declination for the map. Right, when you check the map information for you to calculate the magnetic declination, you are supposed to use the information provided on the map. Right, we go to the map and try to find out so that we are able to get the current declination. If you check, the information is provided here that you are supposed to use. It says mean magnetic declination is that much as indicated on the map as west of true north as of December 2013. So by December 2013, the map information that is provided is giving us the mean magnetic declination. Right, that was the angle which was there for declination for that map as in 2013. Then we are also told that mean annual change. What is the change? The change is 4 minutes westwards as was determined between October 2013 to September 2014. So when you are calculating, you are supposed to find the difference in years. Then you also determine the mean annual change. Then you're also supposed to determine the total change. Then you get your current declination. And so, according to the map information, the angle of declination is 18 degrees and 34 minutes. That is as of 2013. But this angle is going to change because there is a mean annual change of 4 minutes to the west every year. So when you're calculating difference in years, let's say, for example, we're calculating for the information for the current year of 2025. We are now saying 2025 minus the year on the map, which is 2013. That is how you get the difference in years. You get the number of years here. Then after getting the years, in this instance, you have subtracted 2025 minus 2013. Then you go on to calculate determine the mean annual change. The mean annual change, don't calculate it because it's provided for you. You just provide what is given there. Right? In this instance, let's say it's 12 years. Then mean annual change is 4 minutes to the west. Right? Then total change. You are now saying this declination is changing by 4 minutes to the west every year, and it has changed over 12 years. So for total change, you are now saying 4 minutes times 12 to get the total change here. So here we are having 48 minutes to the west. Then the current declination. The angle which was there in 2013, it was 18 degrees and 34 minutes. Then over the 12 years from 2013, it has further increased going to the west by 48 minutes. Then you add this. That is how you get your declination. So you must be mindful of the steps that you must follow to find the difference in years by subtracting the year map on the year on the map minus from the current year. Then you also determine your mean annual change as portrayed on the map. Then you calculate the total change. Then your current declination, you are now adding the total change to the original angle which is provided on the map. Then you got your final answer. That is ultimately how you get those 5 marks. You must present those steps and be able to follow them and illustrate how you are going to deduct and get to the final answer. Then use your answers in 313, 314 to calculate present magnetic bearing from trig station to that one. Then that one is now clear because already you have the map the calculations. What you just have to do here is you take your true bearing, then you add your present declination. So your true bearing, you have calculated it, I said, may around 244. Then you add your present declination. You get your final answer there. That is how you calculate. Then Westleton, the area covered by the orthophoto map is dash from MLO. Right. The area covered by the orthophoto map, you can figure it out on the topographic map here. This red block is representing the area marked by a red that red square or rectangle is the one that is mapped on the orthophoto map. So we want the direction of this area from MLO. MLO is here. So if we check this, we can put our compass over MLO here. It implies that the north is there, the west is here, the east is here, and the south is here. So the question is asking about the direction. So it's basically the west. The landform in block C1 and D1 on the orthophoto. Block C1 and D1 on the orthophoto. C1 and D1. Try to check there in C1. This C1 and D1. You see the nature of the contour lines. The nature of the contour lines. It implies that this is a low-lying area and is sloping going towards this direction here. So what is most likely to be the nature of the landscape as portrayed by those contour lines? It's most likely that could be a ridge. It can be because it says low-lying area. A valley, it probably cannot be an ordinary valley. It's most suitable to be a gorge because if you check, a gorge is very deep. As portrayed by these contour lines, they are bending. It implies that this is a deeper landscape. So basically, the correct response must be a gorge there. Right, I'll move on to the next question. The next question is talking about land use at 6 on the orthophoto map. Right, at 6. You can see there are buildings there at 6. What is most likely to be this place here is suggested by what we are seeing on the orthophoto map. We pick out the responses there. Can it be a cemetery? Can it be factories? Can it be a hospital or houses? If you check on the nature appropriately, this seems like it's an organized institution. They cannot be private houses. Private houses, you can see them here. They are a little bit different from this institution here. This seems to be one institution. So we must look for a formal institution to ultimately look at what it can be. Or we can also try to find a clue by checking on the orthophoto map here. On the topographic map, this is the same feature here that we are seeing. And you see the difference with the residential area here. It cannot be a residential area. So if we check on our responses, the most likely answer would be a hospital for that matter. Then MLO receives seasonal rainfall. Discuss this statement. Refer to the topographic map. MLO receives seasonal rainfall. Discuss this statement. Right, MLO receives seasonal rainfall. We are saying does not receive rainfall throughout. It receives rain during a particular season. What clues can we give there? Or what clues can we see on the map to substantiate that MLO receives seasonal rainfall? Right. If we check the evidence on the map, we have a number of non-perennial rivers. It suggests that there is limited rainfall. And also, if you check, there are some dams there. That is evidence. So when you are saying MLO receives seasonal rainfall and you need to discuss, it means MLO does not receive rainfall throughout the year. It receives rainfall during the summer season and the winters are dry. Right. And then the evidence is what you check. If you see an area, the clues that you can use, check on things like for you to substantiate if they are non-perennial streams or rivers. How do you check those ones which are broken? This line, the blue line is not continuous. It's broken. It shows that river only flows in a specific season and is dry in some other dry season. So it's a one evidence. And also if you check an area with quite a number of dams, it shows that water is a scarce commodity which needs to be conserved through damming. And also if you check some other suggestions like reservoirs, if you see an area with a number of reservoirs, it means also that the area does not have plenty of rainfall. It is dry in some other given seasons. So you just have to check on the map and try to find out evidence to support that the area receives seasonal rainfall. How do the farmers in the area prepare themselves for the possibility of dry seasons? Possibility of dry seasons, the farmers in Emelo, how would they have prepared themselves for the dry season? Right. If we check here, we have quite a number of dams. This, for example, here, this is a dam. This is a dam, as you can see there, right? If you also check, we have another dam. Another dam is here. Yes. And also, there are quite a number of dams that you can actually see, which suggests that these farmers have prepared for themselves for the dry season. They can harvest water from the dams to support their crops, or also their livestock can find sources of water from those dams. That is apparently how those farmers have prepared themselves for the dry season. Right, the following diagram is a cross section from spot height 1738, which is in block B1, to the Red Pot farm in C1. So we are looking at B1 to C1 on the topographic map. Explain how the slope decline might affect the appearance of the slope. Right, we are looking at slope decline. Remember, we have slope retreat and we have slope decline. When a slope is declining, the feature like here Here. We are saying the landform is gradually reducing. At the same time, when the slope decline, the area is going to become lower and lower. The terrain is going to become increasingly getting lower. At the same time, the higher lying landform is also getting. So at the end, it will affect the slope in the sense that the slope angle is going to decline. Like here, you see the angle is sharp, but is gradually declining. It's becoming flatter and flatter. And also the height of the feature is going to decline. That is how it is going to affect because of slope decline. That is how it's going to affect that particular area. Right. And also if we check, the other question is talking about how southwest of the Rodport farm is cultivated. Explain why this is ideal location for farming. We are looking at southwest of the Rodport farm. Right. South of the Desertification, right? Our Desertification farm, if we check here, the Desertification farm is said to be in block C1. Let's check the area to the south in block C1 and the cultivated area to the southwest of block C1. Let's check. This is our block C1, the Desertification area to the southwest. This area here is cultivated. Right. So what we are saying here is, why is it ideal for farming activities? Definitely here, there is going to be, indicate in this area, why is it ideal for farming is on the pavement. This is a lower lying part of the slope, is the pavement, and soil is fertile. Remember on slope elements, the lowest part of the slope, the pavement, that is where eroded material, where that material from the upper parts is deposited there, creating deeper soils which are rich and which are fertile. So that is why it is ideal. It's on the pavement, and being on the pavement, it implies that there are deeper soils and the soils are fertile in that particular instance. So that justifies why it is an ideal area to practice farming in that particular area. Right. We'll move on to the other question. The other question is talking about is a GIS question. We're looking at geographical information systems. Right. With GIS, we want to attempt the question. Give an example. Give examples from this block 4A or N. We are referring to block 2B2 on the topographic map. We want to give examples of line symbols, point symbols, and area in block B2. Right, we go to our map in block B2. Our block B2 is here. If we check, we want to identify a line feature, right? Like what you can see here. I'll indicate in block B2, this is a line feature. And this is a line feature. And also, if you look closely, we can also figure out, unfortunately, because of the resolution of our map, it's a little bit blurry. You can't see properly, but there is also a power line, this power line here. And there is also a hiking trail, though it's not very clear. So about line features, we are looking at those features portrayed as a line. So row of trees is here, and we have a power line. And also we have a hiking trail. Those are our line features as portrayed on the illustration on the map. And also, if you can check, there's also a river here. The hiking trail. And also, if you check, there's possibility of a road. So all these are line features. They are presented in line format on the map. These are line features presented as lines on the map. As we check on the map, we actually got evidence of those features as they are portrayed on the map as line features. Then we also need to check for a point symbol. If we check closely for a point symbol, the point symbol that we have in that block, a point, you have a reservoir. We have a reservoir in that area. That is a point symbol that we have. Then area, we are looking at a polygon feature here. The area symbols that we have cultivated land. Cultivated land is a symbol, it's an area symbol, or there's also a marsh or a flame. Those are area or polygon features on the map, right? So basically that is how you identify the features. We have, according to presentation of features on the topographic map, the vector format, we have line symbols, we have point symbols, and we have area or polygon symbols on the map, right? We move on to the next question. Refer to Fig 3.3 showing the Emelo golf course. Is showing the Emelo golf course. Name the type of data on the photo image. This is a real-time image. What kind of data is it? This is an example of raster data. It's raster data because it's a real-time image. It's an image, this one. It's a photograph. So it's made up of pixels, and hence we are calling it a raster data. Then explain how GIS assisted the developers in the choice of locating this golf course. How GIS assisted the developers in the choice of this golf course. Right, you can talk of topography, determination. They need to consider topography of the area, how the area's topography looks like, or the shape of the landscape. So through GIS, they are able to figure out areas which are suitable, gently sloping or flat areas through GIS, so that they are able to locate and find a choice for the location of the golf course. So basically, when you're checking on GIS, we're looking at how did they incorporate the computer technology in identifying an ideal area for locating the golf course. So topographic determination by looking at the nature of the landscape, looking at the nature of other features around. You can find that information using the GIS as in integrating technology to the study of geography. Right, I think with that last question, it has taken us to the end of the paper, which was also the end of our discussion. So basically, those are the ideas that you must incorporate when you are answering your questions and when you are attempting your examinations, right? You must just be able to figure out on the basic geographical concepts. They will assist you in answering the questions. And it is also mandatory that you have a wide spectrum of reading from different sources, so that you tend to enhance your content, you tend to enhance your knowledge on specific areas, and that will give you an advantage when it comes to answering the questions. The more you have knowledge at your disposal, the easier it becomes for you to ultimately get a very good score for your examination. Thank you for watching this discussion. That is the end of our session.